This is Matt Doctor, and today we are going to discuss about L'Hopital rule and indeterminate forms and how it applies to particular indeterminate forms.
It's Math Doctor.
Before we are going to start, let's discuss what are indeterminate forms and how we used to apply L'Hospital rule. So in limits, when we have given any two functions, let's suppose f of x and g of x, and we have given f of x equals to sine x by putting any value of some constant value of x by applying some value for x in gx also. Let's suppose it's x or something else. So by applying the value so that it can give us solution 0. So the solution of x is when we put x 0, it will be 0, and here we know sine 0 is 0. So when these types of forms divided by it, we get indeterminate forms. So 0 by 0 in any forms. So let's look another examples for e raised to power x minus 1 upon log x. So it's also a 0 by 0 form when we put 1 on both sides. So there are a lot of many other forms exist. So we will discuss how to apply L'Hopital rule specifically into this indeterminate forms. So for other indeterminate forms, we are going to first convert into these forms either 0 by 0 by 0 by 0 or infinity by infinity. So before we are going to I'm going to illustrate L'Hopital rule. Let's look at the 0 into infinity form, how we can convert into by considering some example. Let's see x into cos x. So or x into tan x. X into tan x is the one of, and also cot x. So these are the examples where we are going to use these indeterminate forms, and also this 1 raised to power infinity is one of the form by which by some methods, by same methods, we are going to change it. So by this is 0 and this is tan 0 is also 0, and this is 0 and this is infinity. Cot 0 is infinity, we know. So how we change it into a 0 by 0 by 0 form, this form into 0 by 0 form. So this is very easy. By just x divided by 1 upon cot x, we can put, or just put a cot x divided by 1 upon x. So this is going to be happen when we so then it will be converted into infinity by infinity form in this case, and here 0 by 0 form. So these are interchangeable forms, 0 by 0 and infinity by infinity. So that's why we use it as the base where we apply L'Hopital rules in mathematics in order to find the answer of that limit, that indeterminate form. By applying that limit, first we apply the L'Hopital rule. Let's discuss what L'Hopital rule is. So first of all, we have to convert 0 by 0 form and check whether it is in that form, in that indeterminate form, our specific form or not. So we are going to change. Let's look at the example 1 raised to power infinity. So what we are going to take in this form, we are going to take log of both. We have given 1 raised to power infinity. We have to take log 1 raised to power infinity, then infinity comes outside, and it is log 1, which is 0. So it is again convertible into 0 by 0 form or either infinity by infinity form. So these are the examples. So let's look at the real life example. We are going to use L'Hopital rule and discuss what exactly we are going to use in our indeterminate forms in order to apply our L'Hopital rules. So let's discuss with the help of example. We have given example of sin x and divided by x, which is uh, we have to prove it. So this is the formula which we are derived. So how this formula is derived, first of all we are going to look it. So in this formula we are going to use L'Hopital rule so that we can come out of from this 0 by 0 form to in order to write our answer uh, in indeterminate form, not indeterminate forms. And so we are going to use here sin x by x, that is 0 by 0 form. We know that. So we have to come out from it, so that by applying L'Hopital rule, we can definitely arrive at that value, which is defined in at some value of x, which is given as 0 at value of x 0. So by using L'Hopital rule, what exactly told us, just limit x approaches to 0 is of fx upon gx. If the condition is applied, if there is 0 by 0 in form, then we have to take its derivative. So this is how we get derivative, and it will be same by, this is the scientist name Bernoullis, and John Bernoullis, which who has derived in 17th century and 1605. So he has derived it, John Bernoullis. So it's also known as L'Hopital rules. Is also known as, he has written his book L'Hopital rules. So on L'Hopital's mathematics book. So that's why we have generated this formula. It's also known as Bernoulli's formula. So he has derived this formula that limit of x, f of x of g of x with same limit is equal to its derivative. So this is going to be done here also in the prove for proving the this statement. So we are going to use L'Hopital rules. We are going to first convert this sin x into by taking its derivative, which is cos x, and taking the derivative of x, which is 1, we know. So cos x, now when we put limit x approaches to 0, we write at our answer, which is 1. So this is the thing which is useful in order to find these types of indeterminate forms. So here we are going to use L'Hopital rules. There are many other rules by expanding it, sin x. So this is the most useful rule we are going to use in solving indeterminate forms, especially. So one of the forms which must have to be, which is act as the base form, for which we are going to apply L'Hopital's rules and discuss it, and then we are going to try to convert it. So let's look at another example, which is log x upon e raised to power x minus 1. So let's look at this example. When we apply 0 here and 0 here, it will be definitely gives us value log x minus 1. Actually, it's not the case. So we have to take here 0 actually. 0 is the only one. So this may be the right thing. X square, we can take anything else. X cube minus x square. So first of all, before going to apply L'Hopital rules, we have to check whether it is conditional or not, it is satisfied our 0 by 0 indeterminate form, which is the base form, then we're going to apply our L'Hopital rules. So let's discuss how can we apply the L'Hopital rule on this question. So when we going to put here e raised to power 0, which is 1, 1 minus 1 is 0, we know above is also 0, so 0 by 0 form, so we get our answer easily. But what happened when we are solving forms like x into tan x into tan x or cot x? So here I have already told you we have to first convert into 0 by 0 form. So cot 0 is infinity and x is 0. So then we have to going to take x upon 1 upon cot x, then apply the L'Hopital rules. So in these questions we are going to apply L'Hopital rules. So let's apply the first question and discuss how we arrive at our answer by using the L'Hopital rules, and just by doing its differentiation above. And so this is from the definition of L'Hopital rules. So this is x e raised to power x is e raised to power x of derivative, and also here we have x square minus 2x. So when we arrive, so it becomes, when we put x0 it becomes 1, and here it 0 minus 0, which is, so answer is 0. So this is the method we are going to use to solve our answer of 0 by 0 form. So we must have to note either it's 0 by 0 or that our base form or not. So it's the basic method to apply it. So apply L'Hopital rules. So it becomes very easy for doing a calculation smartly and easy, and in a not lengthy manner, in a shorter way, in a tricky method. So this is the one of the method which we are going to apply in the very high examinations, like high competitive examinations. So these are the very helpful rules which we have to take in mind in order to solve our next calculus series. And I hope you enjoy my lecture, and you can watch my video regularly. And this is the final. You can also apply it, which is 1 upon cot x is nothing but, this is known as tan x. Tan x is secant square x. Secant square x is cos square x. Cos square x is 0, is 1, by putting x cos square x, which is 1 square, which is 1. So this is about the today's topic. So we will discuss the next series about more calculus and how we use L'Hopital rules, and where are the applications of in limits in calculus. And so I hope you will enjoy my lectures series and stay with me. Thank you. Have a good day.